My name is Panos, and I'm a co-founder of NetBiz. And in this part, I'm going to go into details about the hardware we're using, the server, the tests, and the type of statistics we produce in NetBiz. And also, I'm going to give information about many details that I'm sure you'll love to hear about. So Stefano covered the architecture of our product, and we're going to go through each of these pieces one by one. And I'm going to start by a deployment scenario. So typically, our customers install an agent per location, and that's only a rule of thumb. Sometimes they can be more fine-grained, and they can install agents in multiple locations in subnets if they want to monitor a specific subnet. And so the agents are deployed around the locations. They can pick between 5 different types of agents. One is the basic hardware fast internet agent. We have a Gigi agent if they need that. As of today, they also have the option to deploy wireless agents. And finally, we have virtual agents that can either install into their own virtual infrastructure, private or public. And we also offer cloud agents that they can install on our Amazon or Google Cloud infrastructure, and they can use them to monitor from the outside in. Now, going to the agents, let's start with the basic part. So we have these 5 types of agents. The basic one is based on the Raspberry Pi. I think most of you are familiar with the hardware. The specs are there. We give an 8 GB hard disk space for that, actually for all agents. And this hard disk space is used, of course, for the software, but the most part is used to store local results. So if the agent loses this connection from the central server and cannot upload results in real time, stores the results locally and uploads those when the connection comes back up. So we use that disk space to cache results when that's needed. The Gigi agent is based on another off-the-shelf hardware unit. It's called Utilite. It comes from a company that's named CompuLabs. And it has 2 cores at 1.2 gigahertz, so it has higher specs. It can run up to 60 tests now. The Wi-Fi agent is also based on the Raspberry Pi. We put the Wi-Fi dongle on it, and we use that dongle, of course, the driver and the information that the drivers give to display statistics about the Wi-Fi infrastructure from the end user perspective. For the virtual agents, we recommend a 2-core provisioning with 2 GB of memory. Of course, the customer can provision whatever they want, but this is enough to run 60 tests. And for external agent, we provision 1 CPU and half a gigabyte of memory to again support 30 tests per agent. A few more details about our wireless agents. So the idea here is that we have a wireless agent that can be controlled from the wired interface. So there's a control interface that we use to send commands, and the agent uses to send back results to the server. And we run all the tests over the Wi-Fi interface. So also, if the customer don't have wired infrastructure, they want to use the Wi-Fi for the control channel as well, they can do that if they want. But we recommend the wired interface for the control and the wireless for the tests, obviously.
That's quite cool. So you can choose as the customer if you're a completely wireless site or you need it, I don't know, some random location in the business. You can do all your control via Wi-Fi if you want to, or choose to do it. All
right. Yeah. So they can plug the agent in from the wired interface, configure the credentials, and then as soon as the Wi-Fi can connect, then they can deploy it wherever they want. Yeah. Some customers also they plug this into a battery, so they can just have floating agents. If they have an intermittent problem, they throw an agent there for a couple of days, collect data, troubleshoot, and get the agent back.
Yeah, I can see a use there. Yeah, you're hearing reports from people saying, oh, yeah, the boardroom or something like that's not been, having problems or whatever, but you just go and stick it in there for a while, see what's going on.
Or rooms like this with many people, over everything, you can put an agent there. And
yeah, cool.
Just a quick question. Do you guys, maybe I missed this part earlier, so there's an external power brick on it, right? Do you have a PoE? Is that anywhere in the roadmap?
So we use off-the-shelf hardware, and what we use right now doesn't support PoE. So unless we build our own hardware, then we don't have anything like that.
Send you a link. There's a project. Somebody's got a little bitty thing about this big. It's a shim that you can run PoE.
Yeah, you can even buy from the from Amazon like a PoE decoupler, right?
Yeah.
And you can do that, or you can even power them from a USB on your switch, right?
You can power them from a USB?
Yeah, we have customers that have just plugged them in and they just work. It's like,
There's that charger port they put now on Cisco switches to charge your phone on.
He's been on tack for been on the phone.
No, I think that would be a really killer add to
PoE.
PoE. Yeah.
well, yeah. I mean, the thing is that we have tested with a PoE decoupler, and we can, you can do that.
It would be nice from the one cable perspective, right? And
Sure.
I totally get that. What about authentication to like .1x, Radius, that type of thing? Is that fully supported?
So yeah, we support not the X one yet, but these ones are the ones we support, right?
Okay.
So you can upload your credentials to the dashboard. Everything is encrypted. So you send the credentials to the agent and connects to your Wi-Fi.
Okay.
Okay. So one thing is that we run the tests over the Wi-Fi, so you can have all your monitoring tests now over the wireless channel, but we also provide statistics about the channel itself, like the signal strength, link quality, the channels connected to, the bit rate from the end user perspective, and information about the access points connected to. And also from each agent, you can do now an SSID survey, so you can put other SSIDs around your access point, your agent. So if there are any rogue access points in the same channel interfering, you can see what's the signal strength, what channel they are connected to, so you can use that as a way to detect.
Thanks to Marriott, you can't do anything about it now, but
Does it show signal strength for each of the other SSIDs?
Yes, signal strength, yeah. Now going to the central server, so the customer can install it either on premise, and we start with many large customers that they want to have everything on site, so we give that flexibility, and also we can host the central server on our cloud infrastructure, and can have everything on the cloud. Right now we support up to 200 agents, and
Is that 200 like on the on-prem appliance? Is that 200 per cloud account? Like what 200?
it's 200 per installation, right? So you have either on-premise or cloud, then it's 200 agents.
Okay. So my dashboard can have a maximum of 200
Right,
agents.
right. Yes,
Just-
yes.
Okay.
And of course, the server is where we store our historical data. It's the data cruncher that produces our statistics, creates alerts that can be sent either through SNMP to your current collector, or send emails to whoever you want to receive email for specific tests or specific types of monitoring targets. And we make sure that we send as few emails as possible. We know that you may receive like hundreds of emails per failure sometimes, but we try to aggregate alerts in a single email so we can give you like don't create any email fatigue.
So I could get like an email, rather than getting an email for each of 10 different sites saying, Salesforce is down or whatever. Instead, I could get an email saying, these 7 sites can't reach Salesforce. That kind of aggregation.
Right. So we aggregate alerts per target you create, and you're familiar with that.
Yep.
More than other people here. So yeah, if, for example, you in a certain window, like 1 or 2 minutes, right, 5 alerts are created, so you're going to get one email saying all these tests failed from that target to that host. And finally, regarding updates, for both on-premise and cloud servers, the updates are automatic. So we upload our software, our new version, on our repository. The servers on our customers' sites download that locally, and on a pre-scheduled time that can be changed if the customer wants to change that. The new versions apply to the server, and also the server updates all the agents that are connected to it. So everything is handled centrally, and there is no action that needs to be taken by the user.
Do you guys support escalated alerts? Or acknowledging alerts?
Escalated or?
Acknowledging alerts or escalating alerts?
Can you elaborate on that? What do you mean, like?
Like, let's say an alert's triggered for Salesforce, and you can go on the web interface and acknowledge it, or if nobody acknowledges it in 15 minutes, send off another alert to another team.
Okay. No, you cannot do it through the dashboard yet.
Okay.
You can be fine-grained with who receives the alerts. You can configure like on these people, this group receive this alert and that alert, but we don't have that functionality on the dashboard.
Okay.
Yes. Okay, so the third part is the dashboard. So this is where, of course, the user interface is, and that's what the network engineer uses to interact with the tool. So once the agent gets installed, the customer doesn't have to touch it from that point forward. They come pre-configured with DHCP and with the address of the server. So you plug it in, it connects, and then you can control, of course, tests. You can get results from the dashboard. You can control the IP settings. So if you're going to change the address from DHCP to static, you do everything from the dashboard. So you can receive your real-time results on the dashboard, access to historical results, and it's multi-user, multi-role. So if you're going to share the dashboard with the help desk and you're going to do read-only accounts for them, then you can do that, and you'll see in the demo that it's very simple to use, and even I think help desk personnel can take advantage of it. Now, the types of tests we currently support. These are the 5 types of tests, and we have exposed the most common, the options that have been requested by our customers. For ping, of course, you can get real-time historical for the round-trip time and also the packet loss. And you can also define a payload and play with the DFBID. For DNS tests, you can run a DNS test by using the server that the agent was configured with from DHCP, or you can also define your own DNS server to use. For HTTP transactions, we do page fetches, and also you can do HTTP transactions with get parameters. And for each test, of course, we have a periodic interval time and also timeout. So if you don't receive, if you have a timeout of 5 seconds, and you don't receive your HTTP transaction in 5 seconds, this test is declared as a failed test. For traceroute, we give the information of the number of hops, of course, that every test takes, and also the per hop by hop information. And also you can set the TOS value and the destination port of the target. And finally, for iPerf, we currently support only ad hoc iPerf, so we cannot schedule yet, but this is coming up next month. So you'll be able to do a periodic iPerf. So you can do both DCP and UDP iPerf, test multicast forwarding, and of course for UDP you can test jitter and packet loss, and also the TOS value. Any questions so far?
So there's a discussion going on about the 200 agent limit.
Okay.
There's concern about scale. I think a lot of us are thinking this would be exciting to drop into something like an IDF, or if retail chains that have hundreds of locations where you want visibility into all of them. Mm-hmm. I'm assuming that 200 limit is based off of something on the back end. Is that something you're working to improve?
Right, yes. So right now today we can support 200 agents, and you're more than welcome to order 200 agents. But yeah, it's in our...
We'd love it if I had 200 agents, right?
But yeah, it's in the next 6 months. Actually, we're going to be in interop in April, right? So by then we're going to be able to support, to build our backend scaled architecture better, so we can support like hundreds of agents.
All right, so you guys are actively working on the idea of increasing that scale.
Yeah.
Right.
Yeah.
Now, when you get to the point that, like, obviously it's not going to be infinite no matter what you do, are you looking at the option of clustering up servers so that one server is doing 200, another's doing 200, but they kind of agree on what they're monitoring?
Aggregate.
So no, it's going to be like a single interface. Mm-hmm. The backend is going to be, we're going to check the architecture of the backend so it can be more scalable, right? So for example, if you want more than 200 agents, you'll need to spin, more memory and more than one VMs. One is the database, one is the central server, so you can, scale the data processing and the database I/O mostly, right?
Okay, but there's always going to be a limit to that. So what
Yes.
happens when you exceed it? Are you eventually looking at an aggregation
Okay,
idea?
so in that case, there's a user interface limit as well there, okay, that we don't know yet, we'll see, okay. So, but the other thing is that if, for example, we reach that limit, right, somebody might want to put 2 servers, right? Because our pricing doesn't depend on the server, it's on a per agent basis.
Okay.
So if somebody wants to do, I don't know, now 400 agents and they want to spin 2 servers and do one, I don't know, US and the rest of the agents for the rest of the world, then they can spin 2 servers, 200 each, and...
But you'd still have 2 different views into those
yes,
servers.
in that case you would have 2 different views, right?
Okay.
But the goal is to have a unified view, and of course, the dashboard right now, we're going to put another level of abstraction, because if you go to 200 agents, 400 agents, right, it's becoming difficult to manage and view. So we're planning to have another level of abstractions like a NOC type of dashboard where you see statistics on a more higher level than what we currently have.
Yes, that's important, because even if you separate it out, where you've got one in the US, one in Canada, one in the UK, how are you monitoring things between those organizations if you've got 2 different monitoring servers watching both of those?
Yeah.
Yeah, in the future release, you can, the collector basically is the one that collects information from the agents. So those you can spin as many as you want and really like scale out, right? And then it's modular like 200, 200, 200, and then they all aggregate in one server.
Yeah,
so
that's pretty much what you want, right?
Right.
Yeah.
So that would be like and scale out architecture.
Okay. Now, related to that, can you actually have 2 different collectors query 1B?
2 different. So for kind of HA.
Well, not so much for HA, but in the scenario we were just talking about, let's say you've got one for the UK, one for Canada.
Yeah.
But you're also monitoring the connection in between. Can you have the B that's monitoring the connection in between report to the Canadian server and the UK server at the same time?
So technically, this.
Yes, technically it's possible, right? But I don't know. I mean, we have
considered like a hierarchy or a clustering where you have, like I can see deploying this in every one of my IDFs, right? And that's thousands. Whoa. So I can see doing it like regionally, where you have like the East Coast, West Coast, South America, Asia, whatever, right? And then you have regional collectors, and those collectors all report to like a central management console. Is that something that you guys have considered?
That would be the design. Yeah, exactly. So because the collector is the one that aggregates the data, and then they all report one to one.
But then you'd have to find a way too, like he said, to be able to cross, like to be able to get some visibility across
streams.
Right. So okay. Anyway.
Across the streams.
So it's interesting about one per IDF actually, because a lot of people ask us what is the rule of thumb. So generally our recommendation is 1 agent per network location, because I mean it's mostly routing that you're monitoring, right? So end-to-end reachability. So IDF would be good, granular, I would say. The fact is that maybe if you have like a large buildings with a shaft distribution design, multiple STP environment for the old school, that would make sense.
Well, yeah, so the use case, I deal with very large campuses, right? They're very spread out.
Okay.
And I want to be able to test layer 2 issues, fiber issues between buildings, and my campuses span miles.
Okay.
Right? And I've got hundreds of those type of things, right? So I'm going to want to have more visibility, just put one device out there and monitor my WAN links. I want to monitor the campus, the site.
Interesting. Yep.
Great. Okay.
Now, as we speak about all these great new ideas, do you guys have a REST API that I could use and then build my own management system on top of that?
Oh, yes.
Not yet.
And there it is.
The answer is not yet, but it's one of the top requested features of the API. The API is one, the transactional HTTP is another one, so to be able to do like any kind of transaction on the edges, not only like fetch and but good point.
Yep, that's important also because a lot of people requested that data, and we said, okay, let us finish that, the last feature and then move to the API. Yeah.
But what we could do back to the old days, HTML5 scraping.
Right.
Using Flash?
I've heard this story from you before, Ivan. That scraping.
Ivan, what type of data would you like to get from NetBees, for example? Do you think?
Well, just randomly guessing everything you show in the dashboard.
Mm-hmm. Okay.
Yeah.
Okay, great. Fair.
Everything is the answer.
Exactly.
We want it all right now.
Yeah.
So yeah, right now you can receive SNMP traps, but yeah.
The potential I can see here is if you coming back to the campus and widespread deployment, that's where I kind of am interested in. What I see is if you can get the scaling up and the cost per unit down,
right?
Both for the storage, because that's a significant cost, all the traffic going to that server, but also for the probes, then that's a different niche in the marketplace, because the solutions that somewhat resemble this that I've seen so far are very definitely in the one per site model.
Yes,
cost and everything mitigates
Right.
against a wider distribution.
Correct.
Now, speaking about the easy wins, one thing you could do is to have at least some API where you would report the number of problems in this particular monitoring domain.
Great, yeah.
So that he could build his monitoring system and use your monitoring system as one agent. And if you say, oops, I have a problem, then he goes and investigates that dashboard.
Right. Yeah, that's a good point, because if you think again, you need SNMP data, you need flow data, you need active data. We do detection, right, very well. Then you go flow data. What is that increase, that spike in route trip time or packet loss, or SNMP to see what's happening on the router interfaces. So yeah, exactly.
So that would also buy you your escalation paths basically for free. So if someone already has a monitoring system that handles alert escalation, they pull the data out of your system. You don't have to deal with that.
Right.
I still think you should add it, but
no, exactly.
But I mean that's free.
Right.
Now you got me rolling. Nagios.
Nagios, yeah. Nagios, yeah. Yeah, in fact, I mean, that's why we knew it was important to send SNMP traps, to at least send traps to trap collector like Tivoli, and some customer do have that right in place, because at least we're not replacing network monitoring SNMP, we're complementing the solution, so that's why it's really important. Right, but API, yeah, definitely. Also because there are always more like a dashboard, SLA dashboard that need the data that we provide to provide that, service status, right? Like for example, uptime per location, we can gather that immediately, right? And then we'll see how.
So a question just came in from Matt Oswald on Twitter, and he was wondering, and this is a good question, how does the agent discovery work? How does the agent actually discover the server?
Sure. So they come with DHCP, that's one part of it, and we pre-configure them with the address of the server. When we ship them, they come pre-configured with the address of the server.
Okay.
But also, if there's a need to change the server, or we need to ship an agent with factory default settings, right? We have our management system, so the agent can call, and they can get the configuration information and then connect to the server.
Okay.
So I'd call, say, to your public cloud system, which says, hey, your serial number, blah, you actually belong to this management portal over here.
Right,
yes. Goes, okay, that's cool.
Yes, and I mean, we have a system that, we can scan the tag here, and we can, switch agents between different installations very easily.
Love that approach, but that might be problematic in some more paranoid organizations.
The ones
like security-wise.
Yeah.
So this is what happens. Once the agent is configured with a specific destination to connect to, okay, then it doesn't call for a new.
But if I'm paranoid, how do I know that you send the right configuration data to the agent, so he's not reporting the state of my network to someone else or giving someone else the capability to send probes across my network?
Well, not only that, but there are some organizations where there is no direct path to the internet.
Yeah, that's
you have to hairpin through a proxy.
So that's why we send them pre-configured with the address if it's on premise, right?
Okay.
Now,
you send it pre-configured to the customer with the on-prem. So are we derailing you at all? Did you have a zero-touch deployment, whatever type slide coming up, or is this?
So if it's an on-premise, the customer has to tell us at least the IP of the server that they're going to use, right? Okay. And a few information. We tell them which ports we need to open.
IP of the server or the DNS name of the server?
DNS too. Yeah, if they have a DNS.
Yeah, yes. DNS would be far better.
How much you trust your DNS?
I hope we were beyond IP addresses by now.
Some people prefer IP address because say, hey, if DNS is down,
right.
It's like so it's more resilient.
Right. So
basically, just a little bit of bootstrapping has to happen in certain circumstances.
Right.
I mean, I think that's safe to say.
Well,
I mean, that's unreasonable.
So if they give us the information, we give them, the ports we need to have open. One is 2019 and so on and so forth. Right? Like 4 ports, 5 ports, and then apart from that, and the IP of the server, and then we shed everything, right? So they spin up the server, plug in the agents, and that's all that needs to be done.
Say these agents primarily are DHCP, right? I mean, so you're plugging them into your network. Could you not do DHCP option or something like that? That you could configure a server.
From our
right. So think voice or wireless deployments where you give a DHCP option that says option 150 is my TFTP server. Mm-hmm. So when you pull down that address, it points it right at it. That way we would have control over the scope and what it got pointed to. Mm-hmm. But we wouldn't have to configure each and every device. Literally, just plug it in when it pulls down the address and point the right.
Right. No, you don't have to.
Just a suggestion.
Or you could also use DNS, where you get your domain name from DNS or from DHCP, and say netbeast.mydomain.com is
some standard
server.
Right. Yeah.
Yeah, but bottom line, the external inventory management server is just contact once in provisioning. And then, so we generally pre-provision, so it will never send any data in the internet, just to go back to that discussion, but yeah.
So I have to route your IP address internally in my network somehow. There's no native routing, right?
Think about this, like you have, you want an on-premise deployment, right?
What's that?
You want an on-premise deployment, right? Yeah. Full on-premise. Okay, so we ask you, give me an IP address, period, and that will give you a virtual appliance. You load it on your ESXi, right. We send you the agents, and you just plug them, period.
Plug them in. So it's zero. You send it to us pre-provisioned with that DNS name.
Yeah, or IP address, whatever you prefer.
and it just comes pre-provisioned.
Yeah, right.
To go find that DNS on the on-prem solution.
Correct. So as long as you're in charge of the DNS, of course, so it's then your point. Some customer prefers having the IP address for resiliency, right? So if the DNS is down, hopefully you have Anycast DNS, so that's covered, but right, some people prefer IP addresses because rarely IP addresses of servers supposedly change. But right now we don't have a function.
Call me and I'll convince them not to do that.
Yeah, but in the future we'll also implement a function where if you really want to change the IP address of the server, we're going to do that, and the agents will be notified internally without going through our. So think about the inventory management server is only contact when you factory reset, factory default reset the agent, period. For the rest, right, it's always never going to the internet.
That's factory reset, but if you can send them out pre-configured anyway for your settings, then they're pretty much covered, right?
No harm, no foul. Yeah, that's fine as long as we can do that.
Yeah.
For the on-prem stuff.
One other option would be to package your call home system as an appliance that I can install in my network, and then use well-known host name together with a local domain list.
Yeah.
Bam.
Cool. Yeah. Good point.
Okay, great.
Sorry, we railroaded you there a little bit.
No, that's fine. That's fine.
No, this is good. Yeah.
Great discussion.
We were aware that this would be a concern, and that's why we thought carefully about the provisioning. No data in the internet. That's why we also offer an on-premise solution, right, on top of cloud. So it's good.
And I want to say it's plug and play, right? And it is.
I'm sitting here thinking this is good feedback, and unfortunately the name Shark Tank was already taken.
To some extent, you do get that experience coming in here, I think. But I think it's positive feedback. We're not bashing your product. We're giving you this is what we would like to see.
We're giving you this feedback because it's a good foundation. It's just things that we're all selfish, especially those of us who run an enterprise. I'm selfish. I want you to go work on the things that's going to help me, not necessarily them.
I'm going to work on my stuff. I'm much nicer to you than he is.
So do you think overall the deployment and the security concern are fine? I mean, what is your feedback on that? Do you think it makes sense? Is plug and play? The feedback is You said easy to deploy it and provision it, or?
It needs to be it needs to be so simple that it's because if you're going to have a lot of these agents, they literally need to be just completely mindless. And something like getting a TFTP or whatever to point to it, that's going to be, to me, that's like, that would be the ultimate, if I could just blow these out there and if they die, whatever, just slap a new one in, think about it. And as long as they come pre-provisioned with a DNS name, I mean, I guess I could see that being okay. But yeah, when you have to reset them or whatnot,
Yeah, these things need to be dead simple. In fact, frankly, there's too many holes on this, right? I mean, any port that's not getting used on this thing should be completely blocked, right? There should be a network hole, and that's it. Because ideally, it's going to run on PoE, right? And if not, then it should be a network hole and USB for power or something. That should be. That is a significant security. The fact that I can, potentially plug in and pop the warranty sticker off there and put a different SD card in and
yeah, of course.
Well, I mean, it's an off-the-shelf hardware. You can do that regardless if we give it to you or not, right? I mean,
think about a router.
But again, if you've got these deployed in hundreds of offices all over the place. Not everybody has perfect physical security in every IDF somewhere.
Yeah. Well, I mean, it's the same like I go to a router with a console cable or I pop out the compact flash card to a certain extent, if you think, right? Sure. So the idea would be, sure, it should be on IDF for sure, or if you trust your employee, put it on an office hanging off the wall, but yeah, definitely. Well, it would be for IDF, though. That's why there are some, physical access to the hardware, which you can do so much, bottom line.
Well, I'm going to be honest with you. I have monitoring tools. There are other monitoring tools. Like if I was going to put one of these per site, I can do that with a million other tools. What I think the big differentiator with this is, I can, especially if it's PoE and it doesn't have any more ports, I can hang this somewhere, put it above a ceiling somewhere and get my wireless coverage statistics or something from a third party. It's a very simple, very cheap, and also network monitor and lots of other visibility. That's the key that I see with this. Not so much putting one per site. Because I can do that with other things.
You want to say something?
Yeah. So I'll sort of go along the same lines as what Coffee Spiller was talking about. Because I see these as a good tool for deploying in campus environments where you've got a big distributed network with 300 buildings and maybe multi-path between them. Exactly. So I put one of them. I mean, they're small enough and they're likely priced in such a way that I could probably put more than one per building, right? And so do active measurements per, like this is my user net, this is my server net, or whatever, and then have them all report back to a central location. That's where I see a lot of value in them. Once you add V6 to that,
I would especially say, going with this the whole wireless measurement thing, that's going to be really important because when you start looking at a campus network or even just a large building that's got, we just built a building that's got like 900 employees in it. I've got 45 access points, 50 access points in that building at this point because you've got such a high density. There's so many users. So if I have one of these in the building that's connected to an access point, that really doesn't tell me anything about the wireless network. It tells me what's happening at that IDF in that, with that one access point. But I've got a whole lot more of them.
Right.
So when we start looking at things like interferes or things along those lines, it really does scale quickly. And I think that's really good for you guys because you guys can scale, once you can scale your product out really quickly, I think you can sell a lot of them because I think there's a real use case there. But it's definitely, it will require a lot more of them to be able to do that.
Yeah. Sure. One more thing, now that he mentioned campus and multipathing. Spray source ports so that you can potentially hit all the alternate paths. And then if you find that with certain source port you get better performance than with the others, that's a red flag.
Okay.
And in scalability terms, things of tens of thousands, not hundreds, please.
Yeah, we're good.
Well, SourcePorts has another valuable function, which is if you have multiple paths and you are willing to configure policy-based routing or something, you can conceivably steer some traffic to go one way, some traffic to go another way.
Right.
I got just one question about how, and maybe I just missed this in all the hustle and bustle, but when you drop one of these things in anywhere, right? we've talked about how it's got to be super easy, right? You know, plug it in and you're done, right?
That's how it works, yeah.
How would one know that it's on the network and reaching anything by just plugging it in to a port? You know what I'm saying? Like there's no LED that...
So there are LEDs about the Ethernet activity.
Okay.
Maybe, I mean, it's not powered, so you don't see them now. When you test this, you'll see them. Okay.
Okay. So there is some kind of indication.
Right. And there's a power.
It's on the network and it's live.
Right. Yeah.
And then I can go to my monitoring station.
Yes.
So if I have someone at a site that I say, hey, go drop this in, and you know, if there's a green light, we're good, and then just leave it alone.
And within seconds, you should see it popping up on your dashboard.
Okay.
So if it doesn't pop up, that means there's something wrong. You should look at it. But
I know it's subtle, but or small detail, but
I mean, I know Panico will kill us, but also the dashboard you can see on your iPhone. It's not built for mobile, but you can see it, so you can pop it in and check it, and okay, you're good to go.
Yeah.
So you can do that.
There was another good question from Matt Stone on Twitter as well. Is there any authorization that happens between the Raspberry Pi and the server? So the idea is we were talking about this idea of provisioning, zero-touch deployments. Ivan had brought up the concern about, if this thing has a wrong IP address, all of a sudden it's reporting out to someone else's network what I'm doing. Is there any authorization between the Raspberry Pi and the central dashboard to make sure that this is supposed to be talking on this dashboard? So
the agents have a unique ID. The MAC is also used, but we also have a unique ID per agent. And that's used, to identify that this agent, is registered with this dashboard, and it's a unit that, it's supposed to be there.
So if you had an agent that was reporting to the wrong dashboard, it would ignore that data?
Yes, if it was configured with the right ID, yeah.
Okay, cool.
Yeah, also in the system, we just only the agents that were legit can report, right? So, yeah.
Have you considered, or is there already a way to record the location of the agent in terms of GPS, LATLAN,
CDP,
with built-in GPS?
Yeah, GPS.
That
would require. Yeah.
It's not on Raspberry Pi.
Yeah, that would require more hardware.
Put it.
Right, right, exactly. So
automatically no, but I mean it's manual. You can put it on the dashboard, right? You can put location, but it's not automatic.
And it might not work too well deep within buildings.
Yeah, that too, right? So.
But that's a good feature request actually. Like GPS, you're not the first one I have to say, and CDP or LDP, that would be great. And I mean, these are all things that we're keeping in the pipeline.
Well, I'm thinking if you have a bunch of locations or if you have a campus, the last thing you want to have to do is put little icons on a map or something, which might be a nice way to go with the dashboard.
Right. So
if we're doing feature requests, I got two real quick ones then.
I think we're well past, are we?
Well, LDP, syslog export of events.
Syslog export, like send syslog
send syslog for every event to an on-prem syslog
server,
SIM of some kind.
To the address you get in DHCP option for syslog server.
Yeah.
Okay, I'm gonna move forward.
You're gonna just keep rolling. Just keep rolling.
Let's go.
Here are examples of for example, examples of monitoring targets, what we call, and Stefano will show better how a target is defined and configured and how you start tests. So I mean, obviously, to test with 4 different tests, a web server, you can test with a ping test, DNS resolution, with an HTTP transaction, and with traceroute again, the path. And also, if you want to do an HTTP get a query with get parameters, you can also test the backend if people do that. They just take the URL, they put it on our HTTP test with the get parameters, and then you have the backend test on your dashboard. So alerts, we have 3 types of alerts. The up-down is the failure alert. It appears red on your dashboard. And for example, you can configure how many consecutive tests you need to declare a test as failed. For example, if you lose 5 consecutive ping packets, then you're going to see a red tile on your dashboard saying that this alert failed. Then we have performance alerts. And there's 2 types of those. One is the baseline one. So In this case, you collect historical data for a week or a month, and you say that if my test goes 3 times above my 1 month average, then I want to receive a performance alert, and these appear as yellow on the dashboard. And the watermark performance alerts is where you define what's the watermark. So if my ping test goes above 30 milliseconds, the 15-minute average goes above 50 milliseconds, then send me an alert. And now reporting tool is another way, again, to summarize and abstract the performance of your network. So you can compare, per agent, what's the performance for every type of test. You can see the failures for each test and location, and how many alerts have been triggered, right? So in this case, you can see which locations suffer over the last week or the last month, and so on and so forth. And Stefan will demonstrate all this in a second. Now, the data and historical that we keep, a user can choose to keep as much as they want from the settings. And to give you an idea of how much data you can keep with 1 terabyte of disk space in installation with 200 agents, and by keeping 6 months of raw data with this configuration. So we have an assumption that we have this number of tests per agent, which is a reasonable number of tests from what we see from our customers. So keeping 6 months of this raw data, 6 months, right, and 3 years of the averages. So we have the backend daily and weekly averages and monthly averages. You need 1 terabyte of data.
The averages. So that was what was the periods that was being averaged over?
So we have 1 hour, 1 day, hour and day averages.
So 6 months of raw, and then beyond that, hourly, daily.
Right. Yes.
Probably weekly, whatever.
Then we have daily, and then you can. we derive everything else from the daily, because that's, I think, that's good enough.
Yeah, and that's and you can change that if you wanted. Like some people I know really like 12 months of raw data.
Yeah. You do.
User can set that if they want.
And then you see in your dashboard, you choose your options, and you see how much hard disk that requires. So you can provision the right amount, right? So you don't run out of space.
If that's a terabyte, 200 agents,
it's okay.
It's not really a huge amount of disk these days, So that's good.
Yeah, it's reasonable.
Cool.
Can you talk at all about how your backend works? I would imagine if you were keeping, say, 12 months of raw data, and you've got 2 terabytes of data to sift through, and you're trying to pull a report on something, I would imagine performance could see a significant decline. What kind of testing have you guys done with regard to performance at scale of reporting?
Right. So for the historical, as you will see, you retrieve on a day-by-day basis. Okay. So again, for a day's data, you'll see that in the dashboard. Stefan will demonstrate. It takes a few seconds to get the data, right? Now, if you do reports and you do for a year report, might take a few seconds. You'll see spinning until it spits out the results, right? So. And to summarize, so easy to install. Okay, so we still send the agents pre-configured. You spin up your on-premise server or the cloud, your cloud instance, or we host your instance if that's what you want as a customer. You plug in the agents, they come pre-configured, and you're good to go for distributed network monitoring. Any questions for this part of the presentation? Because Stefan will move on to a live demonstration, and I think that's gonna answer most of it.
I've got one more question actually, and we kind of touched, maybe glanced at it earlier, but I've got a lot of Raspberry Pis. I love them. They're awesome, right? There's so many things you can do with them, but they're also Linux that I'm throwing all over my network in lots and lots of locations. So I'm really hoping you're going to tell me there's some really excellent IP tables rules and lots of. How do you handle security on these? Because if I put 200 of them out of my network, and there's a Linux vulnerability, I've also just created 200, attack vectors into my network.
So we don't have any TCP/IP ports open, so you cannot really exploit it, right?
Okay.
The client contacts the server, and not vice versa. So of course, then the controller has to be placed in a management network with the appropriate rules or VPN, right?
Sure.
So, and we, of course, with the software update, push also the security updates. But bottom line, you don't have exploitable.
So you're not listening to anything. You're talking out.
Yeah.
Okay.
What about when you do iPerf between the two of them?
Yeah. Well, but that's spin on a dock and then shut down. So we spin iPerf and then boom, shut down.
So it's only listening while it's running.
Yeah, you got it. In fact, you see some delay because we pause the test, so we don't skew the performance data, run iPerf, and then close iPerf, and go back to monitoring.
And that's a scheduled set time.
So it's coming soon, but right now it's ad hoc.
So potentially I could spin up iPerf and then forget about it and just leave it running.
Oh yeah, you can say
that's sitting there listening.
Right. In that case, yeah. In that case, yes.
The good news is it'll then identify a WAN performance problem. You know.
Right. Exactly. Why?
High bandwidth utilization right now. I don't know why.
Yeah.